Okay, you are able to see my screen?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, so what we have done in, okay, we have, okay, we have, sir, can you mute yourself? Okay, till now what we have done, till now what we have done, that time series is a set of observations which are taken at a particular time and at regular interval. Plus, what we have to learn till now, that whenever we are taking any time series, it should be in a chronological order, and at a time we are going to take only one series at a time. That means we don't have to mix two different series. If I'm taking for Japan index, I'll take all the values of Japan index, which is a common thing, and we all are able to understand this thing. And data will be your with the help of multiple periods. We are not going for only one period. We should have a multiple periods, and always try whenever you are writing any paper or anything, the number of observation should be minimum of 200. If you are going to take less number of observation, you will face some difficulty and your result will be biased. So try to take as short and short regular interval. That means if you are taking daily, it's good. But if you are taking monthly, increase your number of years. If you are taking quarterly, increase the number of years. So that you have to consider very prominently, that these things should be taken care of. My number of observations should not be reduced. And we all have done this thing, that our variable y, and it will be the part of, it's a function of your time t. So that's why we have written y is equals to function of t. T over here will be your time starting from 1, 2, 3, 4, 5. And we have also done this, that if I am going to make any model under the time series, to model the relationship using the data collected over time stock price, that means what we are doing, we are just creating a relationship. That means I am creating the relationship, whatever the price of stock is having today with the previous year price or some other variable. That means you can say the variable that are sitting in the error term or some exogenous variable. Similarly, you can make a relationship of GDP with some other variable or with its own lag. Similarly, your crop yield. So what we are doing, we are forecasting the things. We have also learned that first thing, we are going to forecast the things. Either we are going to make the estimate regarding your mean and variance, or what we are going to do, we are going to make a relationship between more than two variables. So two variables or more than two variables, that we are going to do in spillover effects. It can be a spillover effect, it can be your co-integration, it can be anything. So we are just making a relationship between two different variables. Now, what do you mean by word lags in time series? We have also done that lag means your past. Over here, we are saying that whenever we are making any regression equation, there is one dependent variable and either one independent or more than one independent variables. So over here, I am saying that my dependent variable is depending on its previous dependent variable. For example, if I am saying that today's temperature is extremely high, that means it is extremely hot in today's day. So I can predict that tomorrow's temperature will also be high. So that means I can say that tomorrow's temperature is depending on my today's temperature. So over here, you will see that I have not taken any other variable as an independent variable. I just have taken that today's temperature is depending on its previous day temperature. I am predicting it, that whatever temperature is in today's day, tomorrow also the same kind of temperature will be there. So your dependent variable in today's date is a factor of, is a function of its past. So that's what we name it as a lag in time series. Till now in regression, what we have learned that dependent variable is depending on some other independent variable, but it's not a fact. It can be depending on some other independent variable, or it can be depending on its own past. If it is depending on its own past, we name it as your lag. And there are many examples. For example, over here we have taken the temperature, your rainfall. If you are seeing that again the same thing for the temperatures, today is a rainy season, so I can predict that yes, tomorrow is also a rainy season. You have seen the forecast. If you are moving your phone, you are scrolling your phone, you can see the temperature. That what will be your temperature 2 days ahead? What will be your temperature 5 days ahead? If we are going to any trip, we always go for the temperature, that what will be the temperature in that particular city. So that means what the forecast this department is doing. This department is forecasting the things on today's temperature. So they are predicting the future. So that means future is depending on today's part. So we can say that if I am saying day after tomorrow, tomorrow's temperature, so T plus 1, that means temperature T is today's date, T plus 1 is depending on T. Or I can say T is depending on T minus 1. So it's one and the same thing. So whenever we make the things, it's a lag things. Or what if I talk about your stock price, I can say that today's stock price is depending on its previous day's stock price, or today's stock price is depending on 2 days back stock price. Even you can say that in stock price also, people are predicting that tomorrow the stock price will be increased or not. As I told you yesterday also, even that people are predicting the things that after every holiday, whether the share price is moving up or not, whether the market is volatile or not, whether I should purchase the shares and sell the shares on which particular date. So they are doing prediction on the previous data. So whenever you did the prediction on your previous data, that means your future is depending on your previous data, we name it as a lag term. Now, what happens in lag terms, that right now we are saying that your stock price, your temperature is depending on your previous day temperature, or today's stock price is depending on previous day's stock price. But if I'm talking about temperature, only the previous day temperature is not the factor. There are various other factors also on which the temperature is depending. Similarly, if I talk about stock price, if today's stock price is fluctuating, so I can say that my today's stock price is depending on my previous day's stock price. So do you think that only one reason is there? For that, I can say that stock price is depending upon. There can be n number of reasons. For example, if the company changes its dividend policy. For example, if the company is having a profit and company distributes the interim dividend, or the company has a split shares, or I can say that some external factors, government policy changes, your COVID came, or there is a Russian crisis, or your financial crisis. So there can be n number of factors. Now the question arises that these factors are for the current date, whatever factors are there, these factors are for the current date or for some previous date. So whenever we are saying these factors which are not observable, we are not known, these factors are not known. I'm not saying that my share price is depending on dividend only. I'm not saying my share price is affected by COVID. If I say my share price is today, the dividend is announced. Company announces the dividend today. So do you think that announcement of dividend in today's date will affect the today's price only? It can be, it cannot be. It can also happen that I have announced the dividend in today's date, but the price is affected after 2 days. Price is affected after 5 days. Price is affected after 1 month. So that means if I am valuing the stock price after 1 month, so I will say that today's price is being affected. Why? Because 1 month back dividend was announced. So what I am saying, that dividend lag is also affecting your today's stock price. So today's stock price is affected by its own past also and by some exogenous variable past also. I also gave you the example for sale of the automobile. Sale of the automobile can be depending on its previous sale, or it can be depending on advertisement which is sitting in an error term which is given in the past. So it's not that today's value of anything is depending on what is happening in today's state. It can also happen what has happened in the previous part also. Or let's say if you have watched the videos, I have given you one example over there in behavior. If I talk in HR terms, behavior of a child, if you will observe that on daily basis, a child behavior changes. So what you say, that your child behavior depends on its immediate past behavior also. Or it can also happen that it depends on the parents' behavior also, or there is a fight among the parents 2 days back and which is affected the behavior of a child in today's date, or there is some fight with his friend 2 days back and which is affecting its behavior in today's date. Or let's say your illness is never sudden. If I'm saying that I am feeling sick or I am having a heart attack, what are the various reasons? It's not, it's instant. Instant reasons are not that if I'm smoking in today's date, I'll have a heart attack. It can also happen I smoke completely in the last few years and which is affecting my health in today's date. So that means lag values are there. Whatever you have done in the past, that has the impact in today's date. So that is known as lag value. So if we are doing the regression analysis, as other variables are important, lag values are also important. So we cannot ignore any of the lag value. And for all this, you have to be support of the literature and your support of the theories. So in regression analysis, we are just doing the relationship between your dependent variable and your independent variable. Over here, your dependent variable is the value of the variable that you are taking in today's state, and your independent variable will be lag values of the dependent variable as well as the other variables, some external variables and their lag values also. So what we are doing, we are saying that in time series, we assume that today's value are depending on the previous value. And these previous value can be of the dependent value also, or maybe some other independent values, or maybe some values which are unobservable, which are sitting in an error term. So that's why we have just said that time series depends on the today's value and the previous values. So if we are not taking any lag values, we fail to account for the relationship through time. What does the time series says? That whatever time we are taking, it plays some role in the life of a variable. That's why we are predicting the time series. that today's time is depending on its previous time. That is why it is known as time series. Otherwise, it must have become the cross-sectional analysis. If we are not considering the time, it will be cross-sectional. So there is some relationship between the time. So that's why it's named as a time series. Okay, now let's come to the first part of the ARIMA model. What we have done, we have divided the ARIMA model in 3 parts. First is your AR, second is your I, and third will be your MA term. AR term is known as your auto-regressive model. I will be named as your integrated part. And MA will be named as your moving average model. Now, auto-regressive. The word auto-regressive means when dependent variable is depending on its own past. So that's what we are saying, that auto-regressive models are the models in which value of a variable in current period is related to its own value in the previous period. So if y is your dependent variable, so it is depending on its past. So yt will be equals to yt minus 1. So this will be one of your independent variable. That means your past value will become your independent variable. Now you will see that AR1, I have written AR1 is expressed as, because I am doing for the return series, I am just calculating the return. So return, whatever return I am getting in today's date is depending on some constant term plus returns of the previous day. And there can be some other factors which are sitting in my error term. So you will see that this is my regression equation. This is y, which is the dependent variable, and return t minus 1 becomes my independent variable. But you will see that I have not taken any other variable. I am working only on a single variable. So that's why your ARIMA model is known as your univariate model. We are working only on single variable. Till now, we have learned about the regression. For example, I have given the example for heart attack. Heart attack is depending on your smoking, your high blood pressure, your age. If we are taking these 3 factors and one is your heart attack, so that means we are taking 4 factors. 4 variables are there. But over here, I am not taking any other variable. I am only taking one variable, only one variable. I'm just forecasting the single variable. I'm just forecasting the sales. What will be the sales in future? Or what will be the employee retention in future? What will be the temperature of this particular state, or you can say what will be the temperature of this particular city in future? What will be the population of India in future? So I am predicting only one variable. So it is a regression with one variable only single variable. So that's why we name it as a univariate analysis. Only one variable will be considered. So if I'm saying about the population, today's population is depending on the previous day population. If I'm saying the population of my area is right now 100 people are living in my area. So it's obvious whatever the population was there in yesterday's term, it will be either something plus in population or something minus in population. If today is 100, yesterday maybe 90 or maybe 91. And some people are born over there. So in today's date, it's 100. If yesterday it is 101 and today is it's 100, that means one person must have died. So that means today's population is depending on its past. So I'm not taking any other variable. So dependent variable is a function of its own previous variable. And if I'm saying it's a function of immediate past, that's when t minus 1 yesterday. If my daily data is there, so t minus 1 will be yesterday. T minus 2 will be 2 days before, or t minus p will be your p days before. So if I'm saying this today's value is depending on the yesterday's value, it will be named as AR1. if I'm saying that today's value is depending on yesterday's value as well as 2 days back. So it becomes my AR2. It should be AR. If I'm saying your today's value is depending on n number of previous values, so it will be your ARP. Whatever number of things you are taking, number of lakhs you are taking, that will be that. Now, over here, you will see that I have not touched the E term, error term, because there are various factors, because we are taking the univariate model, and there will be various other factors which are sitting over there in error term, and I am not aware about that. For example, I have given you that return of a share price. It depends on the previous year share price. It depends on the dividend. It depends on the profitability. It depends on your external factors, maybe a systematic risk such as your COVID-19, Russia-Ukraine war, your Silicon Valley error, your Russian crisis, your subprime mortgage. There are so many things due to which the today's return of my stock price is depending. But I cannot observe it. I'm not aware of due to which factor the share price is affected. It's either due to COVID, it's either due to Russia-Ukraine war, it's either to the dividend policy. It's what will be the reason? I'm not aware of. So that's why I am not considering any variable in it. And all the variables are sitting in the E term. Even I am not aware that today COVID came. So today only the price will be affected. The COVID is there in today's date, tomorrow price will not be affected. We cannot say that. COVID has an effect after 2 days also, after 5 days also, after 5 months also. So that means after 5 months, what will be the price is a function of what COVID has given it 5 months back. So I can say that error term is also there and its lags are also there. So if we are considering only the dependent variable lag, we name it as AR term. And if I am considering the lags of the residuals, all the error terms, we name it as a MA term, moving average model. So moving average models are the models in which the values of a variable in current period is related to the values of the residuals in a previous period. And if at the same thing, if I am saying the residual, previous day residual, so it will be MA1. If I take 2 days back, so it will be MA2 and similarly MAP. Now, if I am going to combine these two parts, auto-regressive and moving average. So what we are doing, we are saying that today's value is depending on its own previous value as well as some of the variables which are sitting in the error term in their previous value also. So that's why what I have written, return at the time t is a function of return at t minus 1 as well as some other variables that are sitting in the error term in their lag values also. So it will be considered as your IRMA model and I'll name it as 1, 1. If it comes out to be t minus 1, t minus 2 for the return and t minus 1 for the error term, I must have said IRMA 2, 1. Got it? Any doubt till here? So now let's come to auto-regressive integrated moving average. Now, what does this word integrated tells you? Integrated just tells you the level of stationarity. If I am writing, there is a myth among many of the scholars that on what series we are going to do. I have seen whenever I am judging these conferences and people are presenting their paper over there, and what they did, they always say that we have, they never use R. Normally the people are using E-views and they said that we have just converted into stationarity, and stationarity means your log difference. And they said that it means the data is integrated at level 1. It's a first difference. But do remember, it depends on which data you are studying. That means on which data analysis is done. If you are working on the original data, price data, if you are working on the price data, you will always say that integrated at 1. If you are working on a return series data, you will always say that integrated at level. So remember, if I am saying ARIMA 111, it means today's value. I have not written the return series. It means today's value of a variable is depending on its own value of yesterday, that is represented by this PAR term. And yesterday's value of residual, which represents this one, MA term. And stationarity at first difference, it's saying this middle term. AR term is represented by P, MA term is represented by Q, and integrated is represented by D. So if I am working on a price data and my AR is 1 and MA is 1, I'll say integrated at 1. If I'm working on return data, so I'll write 101. Because AR I have taken 1 lakh, MA I have taken 1 lakh, but I am working on already stationary series. If I am working on stationary series, so it is stationary at level only. So level means 0. So I must have written 101. Any doubt to anyone regarding this? When we are going to write 111 and when we are going to write 101?
Excuse me.
Yes.
Ma'am, see, when we are using the price data, we take it as a written series. We consider written series, but this written series is it a written series is integrated at 1 or it is a
No.
stationary?
Return series is always integrated at 0. That's what I'm saying. Whenever I'm
At
judging
0.
all these things, scholars are saying that it is integrated at first difference, but it is not. It is at level only.
Okay.
Okay. Let's go with this R only. We will just clear it.
Yes, ma'am.
Okay. Now let's import our data series. Attach it. Yeah. Okay, now let me library T-series package. Library. There are 2 packages that we have to library. One is T-series and second is forecast. Because we are going to forecast the things. Okay, now let's make one more subscript. Okay, now what we are saying, there are 2 things. One is my price series and one is my return series. Okay, what we are doing, return series will be your conversion, or you can say log difference of price series. Right. Now let's do it over here. If I am writing the ARIMA model, okay, I am writing my ARIMA model. For example, first of all, I am writing the ARIMA for this, for price series. If I am saying ARIMA, there are 3 parts: AR, integrated part, and MA part. For example, I suppose that AR1 is there. AR1 means T minus 1. YT minus 1. AR1 means YT minus 1. Okay, AR1 means YT minus 1 and MA1 means ET minus 1. Right? This is we are clear. Now, what does this integrated word means? Integrated means on what level your data will become stationary. Now, we all know that price series is never stationary. We first have to convert into log series, then it will become stationary. So what we have done to convert the price series, I have to take the log difference one time only, one time only. So my I will become 1 over here. So if I'll write ARIMA model over here, so it will become 1, 1, 1. Okay, now let's come to return series. My AR term, my integrated term, and my MA term. Again, over here, I am saying it's AR1 and I am saying it's MA1. Now, in integrated part, I have to write where this return series is stationary. It is stationary either at level or your first difference or your second difference. I have to write this part over here in front of I. Now, return series is already stationary at level. It's already stationary. If I am writing the return series only, it is stationary. So that's why I write it 0. Let's come over here. Let's say I am checking ADF.test for the price series. My price series is this one. Original, this is my price series. I am writing N225. N225. So now you can see that it is not stationary. So how it is become stationary? I am writing Rn225 is equals to diff log N225. Now, if I'm going to check it, ADF.test Rn225, it becomes stationary. So that means your price series has become stationary at first difference. After taking one difference, it becomes stationary. So that's what I have written over here, that if I'm taking the price series, integrated will be 1. But now if I'm return series, if I'm working on this Rn225, if I create the model using this data set, so it is stationary at its level only. I have not differenced this Rn225. I have not created one more variable Drn225 is equals to difference. I have not created it because there is no need. It's already difference. It is already p-value is less than 0.05. It is already stationary. So it depends on you which series you are working on. If you are working on price series integrated at 1, I should be 1. So my model will be 1, 1, 1. If I'm working on return series, my model will be 1, 0, 1. And this is the problem which many researchers do it. They always say we are using difference whenever they are using the e-views, because whenever we are using e-views, it always says that you are stationary at level, is stationary at first difference or stationary at second difference. So it shows it. It automatically do it. Because in e-views, you don't have to make any coding. So concepts, people are not aware about the concept, why we are using this term. Because it will show that price series is always stationary at first difference. Got it? Any doubt till here?
Ma'am, so price series, I have to make it a return series. Then I have to put ARIMA model.
I can put it on price series also. R has a backup. It will do it. It will automatically convert it into return series because I am saying integrated at 1. First of all, I am giving the instruction, just convert it into integration or this stationarity and then apply the ARIMA model. If I am writing 0, it means I am giving instruction to R that I am giving you the stationary series only. Don't convert it. Apply the ARIMA model on this series only.
Okay, ma'am.
So
Ma'am,
R is
we
R.
cannot directly fit the price series in the ARIMA model.
We can do it.
Then
We
the
can do it.
integration will be 1.
Yes, you have to just mention it. You have to give instruction to R that I have given you the original series. You have to convert it into first difference. First of all, convert it into first difference and then apply ARIMA model if you are using the price series. If you want to forecast the price, you are giving this instruction. But if you want to forecast the return series, so first of all, you will convert it into return series and you will say that I am applying the ARIMA model on the return series. So return series is already stationary. Please don't convert it into stationary. That's why I'm writing I to be 0. I'm giving the instruction, don't convert it into first difference. Don't take any difference for this. It is stationary. 0 means it's already stationary. You don't have to do it.
Okay, ma'am. Okay.
Got it?
Yes, ma'am. Yes.
Madam,
Yes, sir.
madam, is it possible for that price series like ARIMA 2, 1, 2, 1?
Sir, it won't happen. Price series is always stationary at first difference. First of all, you have to check it whether it should be 2 or not. If it is 2, you can write 2 also. But check it beforehand. You have to make the validity that you are writing 2. Why you are writing 2? Everything will back up with the reasons. For example, if I say that you have to take the admission in a college, right? Or we all are teachers, we are taking the admission of the students. There is some eligibility criteria or not, isn't it? Let's say in my university, there is a eligibility criteria that there is a entrance exam. But along with the entrance, there is some rank system by which the seats are being allotted to the students. But even if the students are rank holders, even if the rank holder at AIR 1, All India rank is 1 also, but still there is some eligibility criteria. For example, the eligibility criteria is that if the person is giving 12th exam, he or she should have 50% marks, at least 50% marks, including English. That is my eligibility criteria of my university. So before, maybe he is AR1, I will check his eligibility criteria, whether he has secured 50% marks with English as a one of the subject or not. If his eligibility criteria is not meeting, he has got, for example, 49% marks, maybe he is AIR1, I cannot give him the admission in my college. So that means we should be clear that I can apply the ARIMA model with 2 also. But whether 2 is the eligibility criteria or not, whether the data is integrated at stationary at 2 or not. If it is stationary at 1 only, so why I'm writing 2? So you can write 2, but before that, check it. And you have to show it in the paper that it is integrated at 2. That's why I have written 2. Got it? Can we move further?
Yes,
okay, now what we are doing in ARIMA model, we are saying that now my ARIMA model is, let's say y is equals to some constant. I'm saying a plus b yt minus 1 plus e t minus 1. Now what I'm saying over here, y is depending on its own term, on the lag of its own term and lag of some error term. Now just tell me whether this is a regression equation or not. Yes, whether this is a regression equation or not.
Yes, ma'am.
This is a regression equation?
Yes, ma'am.
Now, in regression equation, what we have learned, there are certain assumptions. Right? Now, first assumption. What was my first assumption?
Normality.
What was my first assumption?
Normality, madam. Normality of
no,
independent variables.
Yes, residuals should be normal. Normally distributed. So I will check this normally distributed because this is, you have said this is a regression, and yes, this is a regression equation because one dependent is there and two independent variables I have taken. So I have to check all the assumptions now. Residual is normally distributed. So this is the assumption that I'm going to check it. Next assumption, what we have done. What is my next assumption?
No heteroscedasticity. Ma'am.
No. So I can say homoscedasticity.
Yes, ma'am.
Maybe the spelling will be wrong. So homoscedasticity is there. So do you think this assumption will fit in my this model? Yes. When the homoscedasticity is there, I have given you one example that if I am taking the, let's say, expenditure and income. If my income increases and expenditure also increases by same percentage, then it is homoscedasticity. And if your income is increasing, let's say by 10 rupees and expenditure is increasing by 5 rupees, so that means there is a difference. So it is known as heteroscedasticity, right? Now, over here, in this example, I have taken two variables. One is my income and one is my expenditure. Now, do you think in my this regression, two variables are there? Have I taken two variables?
No, ma'am.
No.
ma'am.
If I have not taken two variables, so I don't have to check this assumption. So no need. I don't have to check this assumption. This assumption is valid only when there are two variables. Different when there will be the difference when two variables are there. When two variables are not there, this assumption is not required. Now, third assumption. What was my third assumption?
Autocorrelation,
See,
ma'am. There should be no autocorrelation.
No autocorrelation. So this we are going to check it. No autocorrelation because no autocorrelation is related to your error term, and we are saying that error term is there. No autocorrelation. This we are going to check it. Fourth. Yes, what was my fourth assumptions?
Ma'am, residual should not
No
be
multicollinearity,
mean.
madam.
Residual mean should
No
not be mean.
multicollinearity. Now, what do you mean by word multicollinearity? That means multicollinearity, we have learned that two independent variables should not be correlated. As we have done in our example, export and imports were highly correlated and we use the VIF term, variance inflation factor, or we have just calculated the correlation. And if we say that these two are correlated with each other, so that means we can say our results will be biased. In heart attack example also, I told you that smoking and high BP are highly correlated. So either I have to take BP or I have to take smoking. I cannot take both variables. Now, in my ARIMA model, are you getting some other variable? I have taken only Y. This is dependent variable. I'm saying it is depending on its own past and some error term. There is no other independent variable. If I have not taken any other independent variable, so the question of multicollinearity does not arise. Are you getting my point or not?
Yes, ma'am.
So that means again, no need to check this assumption also. I'm not going to check it. And fifth is zero mean. I'm going to check it. This thing also I'm going to check zero mean of residuals. Because residuals should have a zero mean. Any other thing that I can check?
Madam, explain point 2, madam.
Okay. Now 2 means homoscedasticity. Sir, you can tell me what do you mean by word homoscedasticity and what do you understand by this term?
Madam, the equal variance, madam.
For what? Variance for what? Equal variance of what?
Error term.
Error term. That means there are various variables that are hidden in the error term. They should be equally distributed. Now, do you know that I have taken any other variable in this? Have I taken any other variable?
Only one variable, madam.
Only one variable. If I am not considering any other variable, so how can I say that all the variables should have an equal difference? I cannot judge
Okay.
it because all the variables that are sitting in the error term that are not observable. I cannot observe it.
Okay, madam.
So there is no needed. We need that to check the homoscedasticity when we say that there is some difference. Yes, if I am going to do for the arch and gauge model, because that is a variance model, over there I'll check for homoscedasticity. I will say that there is a heteroscedasticity among the variance. It is changing. But this is not a variance model. This is my mean model. So I don't have to consider for the variance also. Homoscedasticity means no variance. Hetero means variance. And ARIMA model is not a variance model. We don't have to consider it. So there is no need to check the homoscedasticity or heteroscedasticity. What we can do next, we can check the IID for residuals. Or I can check the IID for residuals, or I can say white noise for residual. What do you mean by this IID and white noise for residuals? Again, there is a lots of confusion in the minds of researchers that what is white noise, what is IID? Yes, what is white noise? Name itself is saying that noise is white. Why? What do you mean by white? If you have seen the light is always seen as a white. And it's a combination of all colors, and we are saying it's transparent. I cannot see any white color, but it is transparent. So white noise means all clear error term. That means what are error term? Error term means all those variables that are sitting in the error term, which we have not taken as an independent variable, and they're making noise over there. They are saying that I am also affecting. Some is saying I am also affecting. They are making a noise over there. That take us as an independent variable. We are affecting the dependent variable. That's why we name it as a noise. But white noise means whatever the variables are sitting in your error terms, they are not playing any role in my dependent variable. They are all clear. They are identical. They all are identical. Independent and identical distribution is there. IID, independent and identical distribution is there. That means whatever information I have to take out from my data, I have taken out all the information from my data. Whatever left is there in the residuals, and those residuals does not contain any information which is of my use. I have extracted everything. Or in simple words, I can say that I have to take out the juice of the fruits. I have taken out the complete juice. Whatever part is left is a residual. Nothing is there. No juice is left in that. I have extracted the complete juice. Complete information is being extracted from the variable. So whatever is left is your white noise. Now they cannot make noise. Nothing is left. No information is left in your error term. And if I'm checking IID or white noise, it is covering all my assumptions of residuals. See, this is my assumption of residual should be normally distributed. No autocorrelation is of residuals only, and zero mean is of residuals only. So all the information, if there is zero mean, no autocorrelation, they are not related to each other. It means they are independent. No autocorrelation, the variable for that error term, error ET is not depending on its previous. I'm saying whatever is left, it's not depending. There is no autocorrelation. So that means they all are independent. They are not related. They are independent. And they are normally distributed. That means no outliers are left from where I have to take the information. And zero mean of residuals. Nothing is left in the residuals. It is 0. So I can say the combination of this, I can name it as IID or white noise. Now got it? Any doubt in this?
No, madam.
No doubt? Okay. Now let's go with the ARIMA model, how we are going to make the forecast. Now what the R has done, R has an inbuilt software which will give me the results directly. That means I don't have to choose that which will be the best ARIMA model. It will give me the results. So for that, I have to use the command auto.arima. So you can use the command auto.arima. Now see, I am working on the return series. I'm not working on the price series right now. Let's say I'm working on the return series. Now see, return series means RN225. I am giving the instruction that calculate the model on this return series. So now see, you will see that it has given me the model that AR should be 2. That means 2 lakhs of AR integrated at 0. You will see it's written 0 because I have taken RN225. Integrated at 0 and MA is 1. And do remember, R always works on maximum log likelihood. R has a backup to choose that which model is the best model on the basis of maximum log likelihood. On this basis, we have 3 criteria to check whether my model is good or not. What we have, let's write the 3 criteria. Now, first criteria is I can check it by AIC, a Kaike information criteria. Second is I can check it by BIC, Bayesian information criteria. And third is your maximum log likelihood. These are the 3 criteria by which I will be checking by which model is a best model. If you are using the AIC, always choose minimum value. But if you are finding your best model with the help of BIC, again, always choose your minimum value. And if you are choosing your value with the help of maximum log likelihood, you have to choose maximum value. That's why its name is maximum log likelihood. And mostly they all will give you the same results. Got it? Any doubt till here? But if R is saying this 201 should be the model, but this is the calculation of R. I cannot believe on R. If you want to believe, you can believe. But I'll suggest you can write one paper by believing it. I have also done one paper that I'm going to share it with you. I believe R that whatever R is saying, that is fine. But I wrote another paper with the same data set. The data set that I have given you, I wrote the same paper on this data set only. But I have given you less number of observation and the paper has a more number of observation. And another paper I wrote it when I say that I'm not believing on R. R is saying 201 is the best model, but as per my knowledge, this is not the best model. I will calculate the best model manually. So now let's see how we are going to calculate the best model manually. Okay, now R has given me this model. You can write it in your paper that this is my best model, or you can I can just copy paste it and just write it. Let me do it. I'm just copy paste and let me just write it over here. Okay, let's say I have written my first model. This is my first model. R is 201 and these are AIC is given, BIC is given and maximum log likelihood is given. Now let's go with the model. Let's create another model. So I am creating, let's say I'm now creating model 1. I am creating model 1 is equals to Arima. And I am saying work on RN225. This is how we are going to create the model. And I am giving the order. Order equals to C. Instead of 201, let us give 101. But do remember, in integrated part, it will be 0 only. Don't change this one 0 because RN225 is integrated at 11. So let's see over here. My model is created. Model 1 is created. Now, let me write model 1. Now, see, if my model is 101, this is my AIC, BIC. Now, let's copy it. And let's paste on our data set. This is my model. Let me make one table over here. Now, over here, I am saying this is my AIC, this is my BIC, and this is my maximum ML. ML means maximum log likelihood. And this is my original model that R has given me. This is the model that I have created. Now, if I'll see for the original model that R has given me, AIC is minus and my BIC is this one. Right, and maximum likelihood, it has given it to me. This one. Now let's check it for this. Your maximum likelihood is it's given AIC is this and BIC. Let me check. I have not taken BIC. Okay, it has not given me right now the BIC. If I'm going to compare it with the AIC, what I have told you in AIC, I have to see the minimum value. Which is the minimum value among these two? Which is the minimum value?
Model 1. ma'am.
One
Model
original
1.
one. No, model 1 is a smaller value. This is a bigger value. Yes, in terms of this negative term, this is my bigger value, right? Got it? So model 1 should be the model. I should have taken 101. But what I told you that R always works on maximum likelihood. And R has taken the original model to be the best model. Because maximum likelihood says take the maximum value. It's 3865.41. It's 3865.54. So as per R, this is the maximum value. But as per AIC, this is the maximum value. So similarly, you have to create other models also. For example, I am creating one more model. Let's say we just created
Excuse me, ma'am, I
102.
have a doubt. For
Yes.
AIC, we have to choose the maximum or minimum?
Minimum.
Minimum.
What we have taken? We have taken maximum.
Yes, ma'am.
Yes, we
that's
have
it.
taken maximum. This is my minimum. This is
So
my
the
minimum over
original
here.
would be 100.
And over here also, this is the maximum.
Maximum.
So what we can say in both the cases, original is a best model. Let's go with one more model. So if I'm taking this model 2, okay, let me just do this one. I'm just giving the name model 2. And let me write model 2. Now see over here, AIC. Let's write AIC over here. In model 2, your AIC is this one. And your maximum log likelihood is this one. Now let's compare is 772213. Again, this is the minimum and it's 3866. Now see over here, this is your maximum. This is 3865 This is 3865 and this is 3866. Now in this case, this becomes maximum. And if I'm going to compare all these three, this is not a maximum term. Now this will become your maximum. So AIC is saying take this, but maximum log likelihood is saying take this. So mostly we go with AIC and BIC. If BIC values also given, BIC values are there. I'll tell you how to come with the BIC values. If BIC values are there, we will compare AIC also, BIC also, and maximum likelihood. And whatever, these are the three criteria, whatever two criteria are saying, we will go with that. If BIC is also saying original, this one is the best model, I'll go with this. But if BIC says model 2 is the best model and ML is saying model 2 is the best model, I'll go with this. So you have to make a table, compare it, and try to create at least 10 models. Because I cannot judge anything by taking only one model. And write a paper on that. We are taking 10 different models, and from these 10 models, this is the best one. So the first thing that you are going to make it whenever you are checking your assumptions, or maybe you are forecasting the things, the first thing is you have to create a model and you have to find the suitable model. Which model is a best model? Unless and until you are going to find the best model, we will not move further. Got it? Any doubt?
Madam, how to create a different model, madam? You are saying
Which
that
model?
at least we have to set 10 models.
So you can take now. Now I have created 2 models. Now let me create the third model also. I am saying that now, first of all, I have taken 201, then I have taken 102. Now I'll take 202. I'll take one more model. So I am taking model 3. Now I got this value. If I am taking maximum log likelihood.
Okay, ma'am.
And I'm putting over here model 3 is this value. And your AIC is this value. Let's check for the third model also. Now, if I'm going to see it's 20 again, this is coming to be minimum. All are the maximum because it's a negative sign. As more and more numbers are there, that is a minimum. As less and less numbers are there, there becomes maximum. So minus 7720 is a maximum of this 22. Maximum. You can see it's going into the increasing order. This is the minimum and these are coming to be maximum. If I go with 3866, now it becomes minimum than this. 3866.04. So this is the maximum over here. So in this way, you just go with 10 models and see which is the best model. Now, if I have created these 4 models over here, I'm seeing that original, whatever R has given me, that is the best model only till now. So it's up to you. You have to validate each and everything. Got it? Any doubt till here? No doubt? No doubt? Should I move further?
No, madam. No.
Ma'am, just one doubt, ma'am. Is
Yes.
it necessary to test 10 minimum 10 models?
No. It's not. It's not necessary. It's up to you that how much authenticity in paper you are going to show it. That we have taken so many models, and from these so many models, this is the best model.
Okay, thank you.
You can take 5 only. You can work on auto data rem only. I've taken only 1 model. Now, whatever model you have chosen, which is the best model, the further work will be done on that model only. If I'm saying that this model 1 is the best model for me, or let's say I just create a model, I just create with the word model is equals to this model is equals to what was my original one? We have taken 201. This is the one. This is my best model. I have created now 4 models over here. Model, that is the original model, model 1, model 2, model 3. And somehow I have just to overwrite model 1. I have given the same commands for model 1 and model 2. You can see over here, model 1 is also 102 and model 2 is also 102. So they are overwriting each other. So I'm not going to consider these. So I will be working, I'm saying that this is the best model, but the R is saying that this is the best model, and I have also checked. And after I checked, for me also, this is the best model. So further analysis will be done on this model, the 201. So now let's forecast it. So let's say I am storing the command in forecast underscore rn225 is equals to forecast model. Now I will write that model. That is the best model. For me, this is the best model, model 1. The model which I have given the name model. So this is the best model. And I am saying H equals to 20. Just predict the 20 terms. Now I'll write forecast underscore rn225. And now you will see it has forecasted the next 20 terms. Now you will see we have in return series, just observe the return series. Rn225 is having 1317 observation. So it has given me the observations from 1318, 1319 till next one. All the return series answers are there. So next return is there. And if you make a diagram for this, so you can just write plot and your forecast Rn225, and you can see it has given you the diagram. It will write the model that I have created the forecast, and this is your forecast. And these areas that you are seeing, that is lower limit and upper limit, lower 80%, upper 80%, and lower 95 and upper 95. That means they are saying this is the price and it can fluctuate till here. Now I can create the same model. Let's say I'll just write one more model. Let's say I'm writing model. Till now 3 is done, 4. And instead of 2, I am writing 1 over here. And instead of this series, I can write your N225. This was my original series. And now I'm creating the model. So now what I'll say for, let's say forecast N225 is equals to forecast model model 4 comma H equals to, let's say 20 only. And now I'm saying plot. Yes.
Madam, what is H20, madam?
I want to predict. I want to predict next 20 prices or next 20 returns that I'm going to get in next 20 days. Now see the forecast. I have done it on price series now. Previously, I have done it on return series. If you remember, this is my original price series. This is my original diagram for the price, and now it has forecasted it. This, my price will change like this. This is my forecast. And even I can write the term forecast underscore N225, and it will give me the forecast next 20 terms, starting from why it has given from 1319, because if you will see my original data, this is your original data, you will have 1318 observations. So it has given me starting from 1319 till 1338. So if you will see my last price over here, its last price is for N225 is 28860. So my next price will be 28912, 28859. So this will be my next 20 days price. And I have done it with out of sample. Out of sample means that I have taken all 1318 as a sample. I can also take that, I can validate that whether my model is correct or not. I can take in sample. Let me show you how to take in sample also. If I'm going to, okay, this was my model. I am giving this name model 5 is equals to Rn2 to 5. Now I am giving the instruction that take the data from starting from 1 till 1317 is there. So let's say till 1310 on. I'm giving the instruction, don't take the complete observation, just take this number of observations. I have given that command over here, take this number of observations. Now let us check it, and I'm going to forecast the things. So let's say forecast Rn225 underscore 1 equals to model 5. And let's say we are just taking h is equals to 10 only, or h is equals to, I'll just take 5 terms only. Now I'm just writing forecast underscore this. Now you will see that only 5 terms are there from starting from 1311, 1312, 1313, 1314, and 1315. Let's check whether whatever model we have created is a correct or not. So let me write the tail. Why I'm using the word tail is a command. It will give me last 6 observation of my series Rn225. Now it has given me the last 6 series. Last 6 means if I go over here, I have taken from 1311. See my command 1310. So my next value should be 1311, 1312, 1313, 1314, and 1315. So this value, I have taken tail and 2 to 5. It will give me last 6 values. So last 6 values we are going to do, it will be 1316 and 1317. How many are there? 1, 2, 3, 4, 5, 6, 7. So that means this value is not there. So these are the 6 values that tail has given it to me. Now let's check my 1312 value. 1312 value, my 1312 value that I have predicted is 0.00245 something. And now you will see my this predicted value is 0.0016. It's near about 0.002 only. And if I'm going to check next values, 1313 is minus 0.11. My next term is 0.006. It's also near about. Next term is your 0.017 and it's 0.003. If I'm going to round it off, it becomes 2. It's near about 0.002 and 0.017. It's near about that. Next is minus 0.007, minus 0.003. It's near about the things. So that means whatever model we are creating, that is a good model. Because over here it's written that this much fluctuations are possible. It can fluctuate. Right now 0.007. It can fluctuate minus this or plus this. It can fluctuate between these two parts, or it can fluctuate between 95% level between these two parts. So I have diagnostic, I have checked it that whether my model is correct or not. Now, once I check my model is correct, now I'm going to make a diagnostic check. Now, if I'm going to make a diagnostic check and all the diagnostic check are related to your residuals. We have done that all my tests are related to residuals. So what I'm going to do, first of all, I'm going to create a residual. And how we are going to create a residuals? Yes, you all know how to create a residuals. How we are going to make a residual series? Anyone having any idea how to create? Give any name. Let's say I'm giving the name residual only. Residual is equals to residuals of model. Now my original model is model, so I'll just give the residual of model and it is created over here. Residual. My model is residual is created. Now everything is related to the residual. The first thing is that mean should be 0. So let's calculate mean of residuals. Mean of residual. Now you will see the mean is minus 1.914 minus 0.6. If I'm going to convert it into if I'm going to remove exponential, it will be 0.00000519. So it will be near about 0. So my first condition is fulfilling. Second is that data should be residuals should be normally distributed. For that, I can make a histogram of my residuals. So if I'm going to make a histogram, you will see that it is completely bell-shaped. So your residuals are normally distributed, and for that, and next it is going to calculate the autocorrelation. So I can use for autocorrelation, whether I can use my ACF or PACF. Which graph should I use? ACF or PACF? Yes?
Ma'am, ACF.
ACF. ACF of residuals. Residual. Now you can see that all the variables are within the control limit. Whatever spikes are there, if you are observing, starting from here, no spike is there. No spike is crossing this line. Even here also it is touching, but again you will see that no spike is crossing this upper and lower limit. So that means there is no autocorrelation among the residuals. Always remember, for residuals we use ACF, and for your independent and dependent variable lag, we use the PACF. Or even I can make the plot.ts. For that also, plot.ts and your residuals. It will also show that your mean is 0. You can see over here. If I'm going to make a straight line, every part will fall on the 0. Everything will be 0. Draw a straight line over here. Your mean will becomes to be 0. Got it? Any doubt? Even you can do the L-Jung-Bok test. That means we have done the last part, that your all the residuals should be IID or they should have a white noise. So I can check the box test, which is named as a L-Jung-Bok test. So you can go with that also. And okay, let's check with that also. So I can say that box dot.
Hello, ma'am.
Yes.
Hello.
Yes.
Ma'am, in the forecasting part, we are predicting for the next 2 weeks, right?
We are forecasting.
In
You
the
can forecast either price or you can forecast the returns.
Okay, I can forecast. Let us suppose that we are forecasting for next 20 days. But my question is, in the diagram, in the OX axis, why not the dates are coming? In the plot itself,
because these are the number of observations that why the dates are not coming, because I'm not using the ggplot command. There are different commands for that date should be there. If you remember, yesterday we did the plotting. I used the command ggplot2, and where I used the geometric line command. Geometric lines AES, and then I give the long command that I send it to your chat box. So it depends which commands you are using, and just which command you are using, and which package you are using. If this package, if you will see, just see over here, I'm using plot.ts. It's a simple time series plot. And if you will see over here, plot.ts is a function of stats. It's a basic stats which is inbuilt in R. So I'm not using ggplot. If I will be using ggplot, I can change everything. I can give the years over here, or I can give the dates over here. I can mention the name. I can give the labels. So it's up to you which kind of command you are giving. You can use that also. Years will be there. And I was writing one of the research paper, and this was the reviewer's comment also, that why you have not taken the years. So what I did, I give the complete explanation on this. I can use this graph also, but with the complete explanation that in my diagram, 200 means the 200 observation which lies on this. You can just check it from here, that where the 200 observation lies. So if I'm going to check it over here, you can write in your research paper that 200 observation means your this number of date, they are this year. If I'm going to check it in this, you can see 200 observation. Just observe it, that where the 200 is coming. 200 is coming in 2016. So I can say that 200 observation means 216th year. And similarly, I can say 400 if it is 2016. So 400 observation means this much of year. Either write it this or make it from ggplot. If you are making it with the help of ggplot, it will give you complete years. No problem will be there. Even you can make it date also. But if you are going to write, I have taken 1318 observation. If you are going to write 1318 dates over here, the diagram will become a messy diagram. So that's why we always prefer the dates. Years. And you can write, instead of time, you can write the years over here. So in ggplot, this facility is there.
Got it.
You can make the diagram for this. You can make the price diagram, whatever diagram you want to make it. You can make it even in histograms also. You can give whatever command you want to. You can change the color in ggplot. So whatever you want, you can do it in that part. Got it now? How we are going to do it?
Thank you, ma'am. Yes,
now,
ma'am.
any
Yes,
doubt?
ma'am.
Any doubt to anyone?
No, madam.
No doubt? Now, the last part, how to check the accuracy, whether your model is accurate or not. So just write accuracy and your name of the model. So my name of the model is model. So now you can check the accuracy. Your ME is there, RMS is there, MAE, MPE, MAP. These are your different error terms. So with the help of these MAPE, mostly we use MAPE. MAP means mean absolute percentage error. Mean MPE, mean percentage error. MAE is mean absolute error. So you can see the mean absolute error should be least one. Now MPE is saying infinity. It's not a number. That means it's very, very near about zero. So my model is a good fit. If I'm getting higher MAPE or MPE or MAE, that means there is some error in my model. And if you are comparing 2-3 models, you can compare these also. In whatever model error is least, you have to go with that model. Got it? Any doubt?
It means that in ME, RMSE, MAE, which has the least amount, we will have to choose that.
No. Not from these. If you are taking different models, suppose I have taken the accuracy of model this one. Let's say I just check the accuracy of, I have created another model. Let's say model 2. Now in this you can see the you have to compare different models. Let's say if I'm taking MPE only, MAPE. So MPE of this, MPE of for the same thing as I have compared the AIC, BIC and ML of different models. So you can compare this also. That in whichever model your error is less, you should go with that model. But if you will see over here that there is a competition among the models. See, 001 28 4943, 001 28 4943, 008 769071. Over here, 008 768957. So if I'm going to check it, which model is the best model? Got it? Now, now all the concepts are clear. Now let's do quickly with Stata also. So just import the file.
We were discussing Ljung box also.
Okay, I'll do it. I'll do it. Now, this is my file I've just created. Just make it the time series TS set date. It is set. Now, what we have to do? We have to first of all convert we all know that this is not stationary. So let's check whether this is stationary or not with the Dickey-Fuller test. In R, command is adf.test. Over here, command is dfuller and your N225. And we will observe that your p value is more than 0.05. So it is not stationary. So let's convert it into stationary. So let's calculate generate Rn225. I'm giving the same name. Generate Rn225 equals to same command. Log natural log bracket N225 divided by your N225 and then your bracket and dash N minus 1. Wait, it's Gen Rn225 equals to ln. I think I have not closed the bracket. Okay, now the log term is created. Now you can see it over here. Your Rn225 is created over here. So I have created the return series. Now I'm going to work on this return series. Till now, you can see how I've created. I've used the same command, natural log of original time series. That means at time t divided by t minus 1. Now, any doubt till here? Now, again, in this also, I'm going to create different models. So for that, the command will be arima for Rn225, comma, arima, your model. So I can take 2, 0, 1. So now you can see model is created. This is your values. These are your coefficients over there. So I have created my model. Similarly, you can create the different models over here and then check whether your data is your model, whatever model you are creating, that is a good model or not. Now in this, you will see that AIC, BIC is not there. Are you getting how you are going to check? AIC, BIC is not given. So how to write your AIC, BIC? So you just write EStat IC. Now you will see that AIC and BIC are there. So for each and every model, create the model, calculate AIC, BIC, and then see whether you can, which model is a best model. Now, if I have said that this model is a best model, next step, what we have done, we have to create the residuals. So let's say predict resi. Let's say I'm giving the command resi underscore Rn225, comma resid. Now I have created the model. I have created the residuals over here. Got it? Any doubt in here?
Ma'am, is there any command of like auto arima or something like that?
No, in its data, it's not there.
Or ma'am,
It's there
then
in R.
how can we predict on the data that this model will
You-
be fit or not?
No,
If the
that's
many
for that.
observations are there.
It's what you can do. I just created the model. You see that I have created one model. This is my model. I've created 201. And after that, I calculated the AIC, BIC of this model. Similarly, I will create one more model and I'll create AIC, BIC of that model. So the way I have done it over here, you will create different models. You will calculate AIC, BIC and a maximum log likelihood and then compare which model is the best model.
Ma'am, is
That
there any correlogram or something like that that I can predict that minimize?
Yes. You can make the correlogram. You just make a correlogram of whatever model you are creating, or you for RN225. Just make a correlogram and then you will able to see it. Or I can say that just to make, we know that AR term is basis on TACF. We are aware of, so we can just write RN225. And this is your creation. So you can say it can be at your, I can do it by 1, 2, 3, 4. I can create till 4. Just create different models and check at what point your data will become a best model. You can name
Okay,
it by
ma'am.
this also. It's up to you that how you are going to create a model. But auto.arima facility is not there in Stata. You can just check it by ACF or PACF. Got it? Any doubt? Now, let's say we have done it. We have calculated the residuals. We have checked for P. Now, let's check for the mean, whether the residuals have zero mean or not. So just write summarize. Summarize, and our name is resi underscore RN225. Now, mean is, you can see, 2.01 E minus 0.7. So if you are going to calculate it, it will be near about 0. So we can say that my mean is 0. We can check it diagrammatically also. So you can just write TS line. I'm just giving the instruction. Time series line. Just make a time series line of resi underscore RN225. And I'm saying make a line and with this mean. Make a line with this mean. Now see, your red line you are able to see. This is your mean line. Now it's saying that mean is 0. It's coming to be 0. The same diagram we are getting with R also. The same diagram we are getting with this also. But in this, see, in R, there are different ways. Over here, you can just see the dates are already given over here. But in R, we have to put dates. Got it? Now, in this, if I have to predict the future, so I'll just say predict. There, the command is forecast. Over here, the command is predict. I'm saying predict, and give me some name. So I'm saying forecast. I have given the name forecast. Why? Dynamics. And I will write the date. I think last date is, which is my last date? See, my last date is 25th May 2021. So I'm saying predict afterwards. 25th May 2021. So I'll write date and then I will say predict from 25th May is the last date. So I'll say predict from 26th May 2021. I think some Just write, let me write it again. Predict FRN225. Let me give this name. Predict FRN225, comma, Y dynamic date. Predict from 26th May 2021. Now see, I have said that predict and I have given the name FRN225. It has predicted FRN225. Now over here you will see that label is a long name. It's a long name. I just want to change the label. So I'll say that label variable, and I have given a name FRN225 to be forecasted value. Forecasted RN225. Now see, it has changed the name over here. Got it? How we are going to do it? And now we can make the graph of the forecasted value. So you will write the command ts line RN225, and you have to make a forecasted value of RN225 along with the name FRN225. Now you can see this red line is FRN225 and these blue lines are the original series. Got it? How to do it? Now see, in this diagram, you are not getting the further time values because I have not given any command that whether he has to, Stata has to predict 20 values, 10 values. I have not given any command. So if I have given any command, then only it is going to predict it. So if I want to give 20 values, it will predict 20. If I want to say 10 values, it will do 10 values. And for that, your command, first of all, we have to create the command for that creating the values. So I'm giving the command append add. I'm saying add 20 values, 10 values, whatever values you want to calculate. Now, after that, again, I have to write all these commands. Predict. Let's check whether it has done it or not. No, it has not created because I have given the command later on. I have to give first of all add 20 values, then only it must have added the values. Now, any doubt in how we are going to do a ARIMA model in Stata, or we are going to ARIMA model in your R? Any doubt to anyone? No doubt?
No, ma'am, no, ma'am.
Madam,
We
Yes,
have
sir.
to do this TS
whether the
append
R and
and
Stata will give the same result, madam?
Yes, yes. Both the softwares will give you the same results. Even if you are doing by eViews also, if there is a new software, RATS, you will do by any software, the same results will be there.
ma'am, I have a doubt.
Yes.
This TS append add 20, which is the prediction value of the another 20 from the series. This has to be done before the predict
Yes,
FRN225.
yes. It has to be done. So what I have to do, I have to erase everything. Now, again, I have to give the command append, and then I have to do all these things. Because I forgot to give the command whether it has to predict 20 values or 10 values or 50 values. So that's why in the diagram, if you will observe, it has not predicted any values. Now your doubts. If any doubts are there,
Ma'am, I have one.